Our electricity grids are the unsung heroes of modern life, quietly delivering power to our homes and businesses. The transition to electric vehicles, or EVs, presents a significant challenge to these vital networks. While EVs offer a cleaner transportation alternative, their increased electricity demand will test the limits of our current grid infrastructure. Currently, most power grids are designed to handle peak demand, which usually occurs during the day or evening. However, this peak demand is only a fraction of the grid's total capacity. Average demand throughout the day remains significantly lower than this peak. This difference between peak and average demand is crucial as we consider the impact of widespread EV adoption. If everyone suddenly switched to EVs, charging them all simultaneously during peak hours would overwhelm the grid. Imagine a scenario where everyone plugs in their EVs after work, just as electricity demand for lighting and appliances surges. This simultaneous charging would create an unprecedented strain on the system, potentially leading to blackouts and disruptions. To accommodate the increased electricity demand from EVs, significant grid upgrades will be necessary. These upgrades involve strengthening existing infrastructure and expanding capacity to handle higher loads. Transmission lines which transport electricity over long distances need to be reinforced to carry more power. Distribution networks responsible for delivering electricity to homes and businesses also require upgrades to manage the localized increase in demand from EV charging. Upgrading the grid is not just about increasing capacity, but also about enhancing its intelligence. Smart grid technologies will play a crucial role in managing the complexities of EV charging. Imagine a system that can monitor electricity demand in real time and adjust charging patterns accordingly. By shifting EV charging to off-peak hours, we can utilize surplus grid capacity and avoid overwhelming the system. These smart grid solutions are essential for integrating large numbers of EVs seamlessly. As we electrify our transportation sector, the need for electricity generation will inevitably rise. This demand increase presents an opportunity to transition to cleaner energy sources and reduce our reliance on fossil fuels. Renewable energy sources like solar and wind power will play a pivotal role in meeting this increased demand sustainably. Expanding renewable energy generation is essential for ensuring that the EV revolution translates into genuine environmental benefits. However, relying solely on intermittent renewables like solar and wind can pose challenges to grid stability. Nuclear power, with its ability to provide a constant and reliable energy supply, can complement renewable sources and ensure grid stability during periods of low renewable generation. While the transition to EVs offers significant environmental benefits, it also presents logistical challenges, particularly regarding local grid congestion and fast charging demands. Local distribution networks responsible for delivering electricity within neighborhoods are particularly vulnerable to congestion. The concentration of EV charging in specific areas, such as residential streets with limited grid capacity, can overload local transformers and lead to power outages. Fast charging, while convenient for EV owners, poses additional challenges to the grid. Fast chargers draw significant amounts of power, placing a sudden and intense load on the electricity network. Imagine a scenario where multiple EVs simultaneously use fast chargers at a charging station. This simultaneous high power demand can strain the local grid, leading to voltage drops or even blackouts. Therefore, managing fast charging demands, especially in locations with high EV traffic, is crucial for ensuring grid stability.